Hi there, we're Team MAI, and we have taken part in the Student Robotics competition for 4 years now. In our experience, the hardest part of the competition was always getting the robot to drive in a straight line. Previously, we've tried doing this with regular motors, but failed to do so. So this year we decided to use stepper motors instead. Stepper motors are very precise, and that's why they're often used in 3D printers or CNC machines. Choosing the right stepper motor can be quite hard as well, since you have to balance speed and strength and still look out for a low price. We decided to go with a NEMA 17 stepper motor that had a 5:1 gearbox attached to it. The motor takes 1.68 amps at 12 volts and produces a torque of 20 kilograms per centimeter. Using a website, we calculated that it could manage 1.23 revolutions per second. Based on the torque and the revolutions per second, we now chose our wheels at an outer diameter of 16.7 centimeters. This gives us a total maximum robot speed of 39 meters per minute, and every wheel will be pushing with a torque of 1.2 kilograms per centimeter. To control the stepper motor, we brought a Pololu A4988 stepper motor controller. This is a controller often used in 3D printing, and it can handle up to 2 amps at 12 volts easily. We wired up the controllers like so, connecting the main power input to the 12 volt output of the power board. We connected the motors and the controllers and bridged the reset and sleep pins on the controller. We hooked up the direction and step pins to some digital ports on the Arduino and also connected the 5 volt power supply. Note that the 5 volt power supply has to be connected to the Arduino and not the power board, since the step and direction pins need to share the same ground. We then create a custom Arduino code with 4 different movement methods. One for turning right, one for turning left, one for driving forward, and one for driving backward. All these methods did was set the motors to different directions and then have them turn by a set amount of steps, or in this case ticks. We outsourced this to another method which simply counted down the set amount of ticks or steps and had the motors turn by these individual steps. The last thing we now have to do is to set the maximum output current on the stepper motor controller. This is done by turning a screw on the back of the controller. A voltage measured between the screw and the ground cable gives direct feedback of the maximum output current. We know that our motor needs 1.68 amps. And we also know that the voltage measured times 2 will be equal to the number of amps the controller will output. By filling in our variables and solving the equation, we find out that the voltage will have to be 0.84 volts or 840 millivolts. Alright, let's take a look at the result.